So the first few questions, anybody looking at these saying, oh yeah, I remember how to do those? Please tell me there is somebody. Okay, so just find it on the unit circle. And how do you identify things on the unit circle? The first term is, the second term is, and how do you find tangent? Okay, so you put the y over the x, okay? And secant, you flip or 1 over cosine. And cosecant is the flip of sine or 1 over sine. All right, so which ones do you need me to do? Where's secant of negative 60? If you add 360 to that, you're at 300, right? So it's the same spot as 300 degrees. When you get to 300 degrees, the secant is the flip of cosine, so you flip over 1/2 and you get 2. What about the tangent at 3 pi over 4? Number 6 here. If you go to 3 pi over 4, you have this ordered pair. It shouldn't take you long to figure out the tangent then is just what? Making me cry. What's the tangent here, guys? Garbage over garbage. Yeah, it's just -1, right? Because all this, remember, we just look at the numerator really anyway, because the divisor will always, the denominator will always cancel. So square root of 2 over square root of 2 is 1, and one of them was negative. So let's do this tangent one and be done. Number 5. Go to 11 pi over 6. And this is the ordered pair. So what happens when I put the y over the x? What does that become? Please speak up. Right? Because you got to multiply top and bottom by square root of 3. Everybody okay? Can you do tangents? Maybe? Do you need to do one more? Cosecant at -3 pi over 4. -3 pi over 4 is the same as positive 5 pi over 4. So you get negative square root of 2 over 2, negative square root of 2 over 2. So cosecant is the flip of sine. Well, it's kind of weird, but if I flip that over, what happens? Get -2 square roots of 2 over 2, which is just negative square root of 2. Okay, yep, feeling like everybody's sleeping. The next section on that worksheet talks about finding the trig functions, and you will not have to find all 5 on the final. But basically it's about identifying the quadrant. Does anybody remember how this goes? All students take calculus. Where do we put those? Goes which way? Okay, and this is quadrant 1, 2, 3, 4. And then this actually means what? Because students can put that in there and not know what it means. Yes, they are all positive here. The sine and its reciprocal are the only ones positive here. Tangent and its reciprocal are positive. Cosine and its reciprocal are positive. So this question says what? First of all, I don't know how many people get this wrong. What is that saying? Is less than 0, which means the sine is negative. And this says the cosine is negative. So where is that true? In the third quadrant, right? Because tangent's the only thing positive. So when I go to draw my picture in the third quadrant, it's got to be a bow tie triangle, meaning like one of these guys, right? Got to be with the x-axis. Cosine is adjacent, or x over r. Now when I do Pythagorean theorem, I get 5, What number or what sign goes here though? Yeah, it needs to be a -5 because of the quadrant I'm in. Everybody okay? So then if it asks me to find, let's say cosecant, it isn't going to ask you to find all 5, but if it asks me to find cosecant, it would be what? Seriously, guys? Yes. Cosecant is the flip of sine, right? Sine is opposite over hypotenuse, so I need hypotenuse over opposite, which would be 13 over -5. And you could find any function after you've drawn the picture. So what quadrant is this one in? If the cotangent is negative, so is the tangent. And what is this saying? The cosine is also negative. So where is tangent and cosine negative? Yes, quadrant 2, where sine is the only thing positive. All right, then when you label, how's this going to go on your triangle? Because some of you will get the right quadrant and you won't label it right. Cotangent is what? Flip of tangent. Okay, so tangent is -7/24. So where do I put those on the picture? Seven would go where? Okay, yeah, opposite, right? Y is sine. And this is sine over cosine. Cosine is adjacent. Better? Put them in the right spots. But something's wrong with what I did. Yeah, one of them is negative, and only one of them. But because I went left, it has to be this one, and this is up. 25, is that 7, 24, 25 is the Pythagorean triple? Okay, so then if it asked for cosine, it would just be -24 over 25. We can all do one of those. We can draw. Okay. These are all solutions. This is an equation, so there are infinite solutions unless they tell us otherwise. Where is the sign negative square root of 2 over 2, guys? Look at your unit circle. Somebody please answer. Where's the sign negative square root of 2 over 2? Okay. And because it says all solutions, you have to put what on the back? It's a sine curve, so it's going to repeat every 2 pi. All right, number 10, where's the cosine 0? Okay, and you can write that and then put plus or minus 2 pi n. There's a shorter way to write that. Because they're straight across from each other, you could, for number 10, you could put pi over 2 plus or minus pi n, because it just goes straight across, but it's fine either way. Everybody good with it? Tangent is tricky. How do you have to find tangent? You're going to have to think about putting the y over the x, right? Until you figure out which one comes up with a 1 or a -1. Anybody know? Yes, one of them is 7 pi over 4 and 3 pi over 4. And those are straight across from each other, and the tangent has a period of pi n, so you could just put pi n. If you put 2 pi n, it wouldn't be wrong as long as you listed both of them. If you put pi n, you don't need both of them, but yeah, anyway. As long as it covers all your bases, I'll be fine. All right, these, they do the same thing, but what? Only give answers between 0 and 2 pi. What would I have to do first on 13? Divide by 2, so I'd get where is the tangent 2 square roots of 3 over 2, which would just be square root of 3. So what ordered pair am I looking for that would give me this? Tangent is square root of 3. Tangent is y over x. So I need square root of 3 to be back here, right? And what is it really over? Nope, the 2's canceled. It's over 1. Now there's nothing. So there'd have to be a 1 here. You looking for that spot? Right? It's going to look like this on your unit circle. Where does that happen? In 4 pi is where it's negative, negative, right? But that would turn out positive. And then the other one was pi over 3. Yep. All right. What about, well, that one's just the opposite. If I subtract 3 from both sides here, I get 1/2 equals cosine. Where are the two places, guys? Easy question. Where are the two places where cosine is 1/2? Pi over 3 and 5 pi over 3. And you get no plus or minus anything on those because it's just between 0 and 2 pi. That's solving trig equations. Everybody feel a little bit better? We did get far more complicated than that, but those are the basic ones. Okay. These are your double angle things. Whew. Let's try basic one first. These are the U substitution problems. When this number is in here, you don't get rid of it until the end of the problem. So you say whatever this is 1/2, negative 1/2. Where is the sign negative 1/2? The sign is negative 1/2 at 7 pi over 6. And every 2 pi after that. And the sign is also negative 1/2 at 11 pi over 6. And every 2 pi after that. We good? How did we finish the problem? Do you remember? Yes, or take 1/4 of everything. And it literally means everything. So the answer became theta equals 7 pi over 24 plus or minus 2 pi over 4 would be the same as pi over 2. And this would be 11 pi over 24. Okay, that's not working for me. Plus or minus pi over 2n. All right, let's do the tangent one just because we seem to not be able to figure out tangent. Where is the tangent 1, guys? Positive 1. And most of you would write it this way, even though you actually don't need both of those solutions at all. You could just say plus pi n. But if we wrote it this way, what would we still have to divide by? So you got to divide by 3 or multiply by 1/3. So you would have pi over 12 plus or minus 2 pi n over 3 and 5 pi over 12 plus or minus 2 pi, 2/3 pi n. And there's a way you could write that shorter, but that would work. Right? Now you remember kind of those? All right. This is such an easy section on the quiz, and there's 2 or 3 questions on the final, I mean. But the problem is you don't have your colored unit circle. These are the ones we use the colored unit circle for. And you don't get a colored unit circle. So do you remember it's at the bottom of the sheet? You will have this reference sheet. What is it telling you down at the bottom? Very bottom, it says for sine, inverse, you have to have answers between this and this. What is that telling me? I need to look only in quadrants. Yes, pi over 2 is here, negative pi over 2 is here. I need to only look in quadrants 1 and 4. But if I look in 4, I have to rename them as a negative. All right. Cosine, inverse cosine down at the bottom, it says is 0 to pi. That's the easy one. You can look all the way here, right? Quadrants 1 and 2. Inverse tangent is negative pi over 2 to pi over 2, and you can't actually include either one of those, but it is still these same two quadrants, 1 and 4. So we just need to be really careful, though, because if we answer something in quadrant 4, we have to call it by its negative name. I really wish everybody's paying attention, because these are so easy if you get this. All right, where's the sign 1? Please answer. Where's the sign positive 1? Where is there a y value of 1? Anywhere on the unit circle. Pi over 2 and you're done. Number 22, these always only have one answer. Where is the cosine square root of 2 over 2? Only one spot that we can look at in quadrant 1 or 2, and it occurs at pi over 4. Where is the cosine 0? Where is the sine negative 1/2? This is the one that'll be on the quiz, probably the final, something that ends up in quadrant 4. Because sine, be careful guys, sine we had said had to be in quadrant 1 or 4. So when you find a negative, sine is at 11 pi over 6, but you can't call it that. What do you have to call it? Negative pi over 6, okay? Tangent, oh, we hate tangent. Okay, this one is tricky. Tangent is negative. Okay, I'm looking in these two quadrants. So if it's negative, it has to be in quadrant 4, right? There's only a couple choices. If you go to quadrant 4 and you look at the first one, if you put the y over the x, you'd get that. Go to the second one, if you put the y over the x, you'd get that. If you go to the third one, you put the y over the x, you'd get that. Yeah. See, this would simplify to square root of 3 over 3, and it would be negative. You just look at the y over the x, you should be able to figure out which of the 3 it is. It's not that many of them to look at. And you can't call that 11 pi over 6, so you have to call it negative pi over 6 again. Sine negative square root of 2 over 2. Negative pi over 4, because it's at 7 pi over 4. Everybody okay? All right, this is 2-step, and there's one of these on the final. What is the tangent at pi over 4? So it would be square root of 2 over 2 divided by square root of 2 over 2, which would be 1, right? And then it's asking, where is the cosine 1? Cosine is x is 1 at 0. Because right up here, it says cosine has to answer between 0 and pi. Okay, and that's when you see that little bitty negative 1 up there, that's when you have to check these ranges at the bottom. Okay. Let's finish this section though, because the last two are even different, but let's do this one. What is the cosine at pi? Negative 1. Where is the tangent? Negative 1. It's in the fourth quadrant again, so it's one of these down here. This is the one that would turn out -1. And what do I call that? Yep. All right. Does anybody remember how we do the last two? Very good. What quadrant would a positive inverse tangent be in? Well, the only place everything's positive is quadrant 1 for these. So we have this, and you draw it the way I would suggest you do it anyway. You can use Pythagorean theorem without drawing it, but I wouldn't. Tangent is from here opposite over adjacent. If I do Pythagorean theorem, I get 13. So what is the cosine? 5 over 13. Everybody's good. You had to do Pythagorean theorem to find that missing piece. Okay, inverse cosine. Again, it's quadrant 1 because it's positive. Cosine is adjacent over hypotenuse. We use Pythagorean theorem. You should get a 4 here. What's the secant? Yeah, it just flips over the cosine, so we really didn't even need to draw that one. It's a weird one. Better? 10 minutes of trig review a day, and we'll be ready for the final. 20 minutes, that was.